Title: Binomial Distribution. Introduction. The binomial distribution is used to model scenarios where there are a fixed number of trials, each with two possible outcomes, success or failure, and the probability of success is constant across trials. Applications. Quality control. Example, in manufacturing, if a factory produces 100 light bulbs, and the probability of a bulb being defective is 0.05, the binomial distribution can be used to determine the probability of finding exactly 3 defective bulbs in a sample of 10. Medical research. Example, when testing a new drug, researchers may use the binomial distribution to estimate the probability of a specific number of patients responding positively to the treatment out of a total number of trials. Marketing. Example, in a marketing campaign, if the probability of a customer buying a product after receiving an email is 0.1, the binomial distribution helps estimate the likelihood of a certain number of purchases from a fixed number of email recipients. Election polling. Example, pollsters might use the binomial distribution to predict the probability of a certain number of voters favoring a candidate based on a sample size and the estimated probability of supporting that candidate. For example, the number of telephone lines busy at an instant of time is a binomial variate with probability 0.1 that a line is busy. If 10 lines are chosen at random, what is the probability that first condition is no line is busy, second condition is all lines are busy, third condition is at least one line is busy, and last condition is at most 2 lines are busy. This C program calculates various probabilities related to a scenario involving telephone lines using the binomial probability formula and factorial calculations. stdio.h and math.h are standard C libraries. stdio.h is for input-output operations, and math.h is for mathematical functions like pow. Function definitions. Function name factorial. This function calculates the factorial of a given integer, n. It's a recursive function that returns 1 for n equals 0 or n equals 1, and otherwise computes n factorial n-1. Next function is combination. This function calculates the combination n choose r, ncr, using the factorial function. It returns n factorial divided by r factorial into n-r factorial. Next function is binomial probability. This function calculates the binomial probability, p of x, for given parameters. X is number of successes, n is number of trials, and p is probability of success. It uses the combination function and pow function from user input, prompts the user to enter. N is number of telephone lines, and p is probability that a line is busy. Calculations. Probability that no line is busy. P of 0 calculates q to the power n where q equals 1 minus p. Probability that all lines are busy. P of n calculates p to the power n. Probability that at least one line is busy uses 1 p of 0. Probability that at most 2 lines are busy uses a loop to sum they. Probabilities, p of x for x equals 0, 1, 2. Enter the number of telephone lines equals 10. Enter the probability that a line is busy equals 0.1. Probability that no line is busy equals 0.3487. Probability that all lines are busy equals 0.1 to the power of 10. Probability that at least one line is busy equals 0.6513. Probability that at most 2 lines are busy equals 0.9298.